Good evening to you all. Waiting for this session. Yes, Adya from NPS present. Good evening, Aditi Shetty, Nishant. Yes, as we discussed yesterday regarding application of angle sum property, exterior angle property, and transversal even intersects the parallel lines. What are the conditions, property it satisfies? Based on that, we did many more problems. Today, I will do one or two questions from lines and angles. Then immediately I will start the new chapter, circles. Okay. So continue in unruled book only, the circle chapter also. Construction, after construction I did lines and angles, then next is circles. Okay. In usage of angle sum property, we did one question, that is the bisectors of the base angles, internal bisectors of base angles intersect at a point, then that angle is equal to 90 degree plus half of the angle A. That is internal bisector. In the textbook you have external bisector question. External bisector is 90 degree minus half of angle A. So there is a difference between internal and external bisectors. Okay, na? And also yesterday we discussed about the internal bisectors of co-interior angles on the same side of the transversal intersect at right angle. That is also most repeated important question. So now I will do this question. I think it is in exercise example 8 from the textbook question. Anyhow, I'll give the figure. Question, it is written, that worksheet I forgot to bring here, I will send later. Okay. Take the figure. The sides AB and AC of triangle ABC, AB and AC of triangle ABC, when produced to point E and D, produced to point E and D. Take the figure. The sides of triangle ABC, AB and AC reduced to point E and D. If bisectors BO and CO, this is the bisector BO and CO, intersect at point O, we have to prove angle BOC equals 90 degree minus half of angle A. This result is for external bisector. What I discussed in earlier class, that was about internal bisector. This is external bisector, internal bisector. Take the question. Okay, na? Right. Given in triangle ABC, AB in triangle ABC, OB and OC are the bisectors of angle CBE and angle BCD. BO and CO are the bisectors of the exterior angle. This is external bisector. When the side is produced, angle CBE is an exterior angle, BCD is another exterior angle, where BO and CO are OB and OC are the bisectors of exterior angle. To prove, that is, the external bisectors of exterior angle by external bisector, its point of intersection is BOC, is 90 degree minus half of angle A. This is the result we have to prove. Okay, na? Next, proof. Proof, what we can write, in triangle ABC, angle A plus angle, I will name this as angle 1, this as angle 2. Angle A plus angle 1 plus angle 2 equals 180 degree. Are you following? Just to see, dividing LHS and RHS by 2, what we get? Angle A by 2 plus angle, if I name this, okay, angle 1 by 2 plus angle 2 by 2 equals 90 degree. Take it as result 1. Okay, na? Next, since OB is the bisector, this is the bisector, so half of this angle will be angle CBO. Here angle EBO and CBO are equal because OB is the bisector. Okay, but total angle here it is 180 degree. So we can take angle 1 plus angle CBE equals 180 degree. Therefore, half of angle CBE equals 90 degree minus half of angle 1 by 2. Half of angle CBE is this angle. It's clear? Sum of 1 plus this angle is together 180 degree. When I divide, we get half of angle CBE as, we can write it as angle CBO equals 90 degree minus angle 1 by 2. So other part also we can consider. Since CO is or OC is the bisector, OC is the bisector, so we can consider these two are equal in measure. Angle 2 plus angle CBE, so here angle BCD equals 180 degree. So half of angle BCD equals 90 degree minus half of angle 2. So we consider half of angle BCD as angle BCO. Angle BCO equals 90 degree minus half of angle 2. Instead of 1 and 2, I will take it as x and y. This is x, this is y. So that will be easier because by 2 it will get cancelled, simplified. X, this is y. So 1 can be taken as x. This is x by 2. X by 2. This is y. this is y. Okay. So instead of taking half of 2 and all, you may get confused, so I use the letter there. So now we have CBO equals this, BCO equals this. Okay. So now again take the another right triangle angle sum property. Just see, later you can write. The other part of the triangle is in triangle BOC, angle CBO plus angle BCO plus angle BOC equals 180 degree. That is because of angle sum property. We can write CBO as 90 minus x by 2, 90 minus y by 2 plus BOC equals 180 degree. Here 90 degree, 90 degree, 180 get cancelled. Angle BOC equals plus x by 2 plus y by 2. But see the result, x by 2 plus y by 2 can be taken as 90 minus a by 2. Therefore, angle BOC equals 90 minus angle a by 2. Write the reason from the result 1. This is the result we have to prove. So in the earlier we proved the internal bisectors meet at a point. The measure of internal bisector is 90 degree plus half of a by 2. This is the external bisector. When it bisects means these two angles are equal, these two angles are equal. We can consider half of angle CB as this angle, half of angle BCD as angle BCO. So in the proof we have taken CBO and BCO, and again applying angle sum property to the base angle, you will get the result. So if you are completed the beginning part, I just tilt like this so that you can see complete answer. Okay na? Please check it once again. Any doubt you can give the message. I can give up the answer. Is clear to everybody? Any doubt? So first condition is using above triangle ABC and applying angle sum property and dividing LHS and RHS by 2, you will get this result. Here itself you can write x by 2 plus y by 2 is 90 minus a by 2, so that we can directly substitute here. If not, keeping this as it is, again you have to mention since it is a bisector, then consider the steps and express in CBO and BCO. They are the bisectors of the base triangle. Then substitute to the angle sum property result, you will find the result. Okay. So the same condition you will get it as a MCQ as what you say, if the internal bisector intersect at point, then that angle equals 90 minus a by 2, 90 plus a by 2, a by 2. Like that, you may get the same descriptive type questions as an MCQ question also. So while practicing for the test, each and every notes, key points, what and all I will explain, listen carefully and work out carefully. Okay na? I will move on to the next one more question. Actually, That is an activity question. We have to do it at school level. Now I am showing that it is also a textbook question. Okay. I don't want to give up the lengthy, and I included this question in the worksheet. Today after the class I will send so that you will get which question I have answered here. Take the next question. And you have learned in light chapter in physics, that is, when a ray is incident on a line, it will reflect back. Then the angle of incidence is equal to angle of reflection. And incident ray, the reflected ray, the normal drawn at the point of incidence or in the same plane. This is the law of reflection. This question we make use of the law of reflection. Okay, take the figure. Is all completed? Here they are considered AB and CD are two reflected objects mirror. Name it as AB and CD. It's a textbook question. So this shows that the reflecting part of this mirror, and this is incident ray. This is reflected ray. Again incident ray, reflected ray. Okay, I am showing with the arrow mark, and these are the perpendiculars. We use the word normal, drawn at the point of incidence. Normal means perpendicular. When the lines are perpendicular, we know that they are parallel. Okay, please take note the figure. They have given up the name as PQ and RS. This is A, B, C, D. A, B, C, D. We have to prove AB parallel to CD. So to show the lines are parallel, there should be alternate interior angles equal, corresponding angles equal, or sum of co-interior angles on the same side of the transversal are equal. Okay, na? So when AB is incident on the part PQ, angle between this is angle of incident, angle of reflection. I think it is not the new part. In 7th itself, you have studied about laws of reflection. Incident ray AB, BC is the reflected ray. I have drawn a perpendicular, name it as M and N here. The perpendicular, so this is angle of incident, angle of reflection. Here to this reflecting part, this will be angle of incident and this is angle of reflection. Taken the figure properly. So here you have to I'll read the question once. Listen the question. In figure, PQ and RS are two mirrors placed parallel to each other. An incident ray AB strikes the mirror PQ at B. The reflected ray moves along the path BC and strikes the mirror RS at C and again reflects back along CD. Prove that AB parallel to CD. Okay? Here, to prove AB parallel to CD. Construction. What construction we have done? Draw BM perpendicular to RS and CN perpendicular to PQ. They are the normal means perpendiculars drawn at the point of incidence. Early reflect out, that point is called incident point. Reflected back, reflected here. Okay. Next, proof. Just to see, later you can answer. Just to see the writing and my explanation, listen the explanation. Proof, since BM and CN are perpendiculars. Therefore, BM is parallel to CN. That is, when two lines are perpendicular to each other, they are parallel. That is one of the property. When they are parallel, when BM is parallel to CN, BC will act as a transversal. Therefore, angle 2 equals angle 3 bracket alternate interior angles. Okay. Next, here angle 1 equals angle 2, angle 3 equals angle 4. But angle 1 equals angle 2 and angle 3 equals angle 4. Reason, angle of incidence is equal to angle of reflection. Okay. Angle 2 equals angle 3 since BM is parallel to this. Angle 1 equals angle 2. So what we get, which implies we can take angle 1 equals angle 2 as 2 is equal to 1, therefore angle 1 equals angle 4. This is result 2. Angle 1 equals angle 2, angle 3 equals 4. So I can replace 2 as 1, 3 as 4. Add in what you get? Angle 2 plus angle 1 equals angle 3 plus angle 4. This is one way, or we can say since they are equal, 2 times angle 1 equals 2 times angle 2 also you can write. Angle 2 plus angle 1 is together angle ABC equals angle DCB, which implies AB parallel to CD because they form alternate interior angles. This is converse of alternate interior angles. Is it clear? That is, when we show the alternate interior angles are equal, by converse the lines must be parallel. When the lines are parallel, alternate interior angles are equal. When alternate interior angles are equal, the lines must be parallel. Therefore, AB is parallel to CD. These are the two main questions which is in the lines and angle chapter also, which carries 4 marks or 3 marks in the test type. Okay. Now take it down. Now I will slowly move on to new chapter, circles. Circle chapter is not deleted, children. There they are given two theorem. Theorem 10.5, that is one and only circle. Okay, you just take it down, then I will give up. I will give the instruction, don't confuse. Is clear? After that, please inform me so that I can proceed. Completed? Yes. Like lines and angles, here also some definitions. We'll go with this introduction of the circle chapter. Slowly we have the theorems to simplify. Yes, we'll go on to the new chapter, chapter number 10, circles. Same circle continuation you will get in 10th standard also. This is very important chapter. In 10th also, based on the circle property, you have geometrical construction and also separate circle chapter. So what you are going to study in 9th standard, that will be carried to the 10th. In this chapter, they have deleted only two theorems. Usually those two theorems we are not doing in the class also. Theorem 10.5 and theorem 10.11. So don't be in a confusion mood. This chapter is not for your exam point of view. Okay, na? If possible, I try to cover all the chapter whether it is included or not, because if it is helpful for the next year continuation, though it is deleted. So don't bother about it. Please listen the explanation of concept under circle chapter. So we have studied right from 4th or 5th standard itself. A circle is a closed figure. It has no length. It has no dimension. It is a closed figure. Okay? Or closed curve. Then after moving to the next class, we said that circle is shaped like a round and it has no dimension. We can draw a circle using instrument called compass. And further, when we go higher classes, we define, yes, no corners and sides to a circle, yes. Okay, then we define in higher classes, circle is a set of points which are equidistant from a fixed point. How will you get that concept through figure? I will show you. Like this, circle is set of points which are equidistant from a fixed point. What we call this fixed point? Circle is a set of points which are equidistant from a fixed point. What we call the fixed point as? What we call that, you might have knowing that. But we say that point O as no, it's not the radius. Yes, the center of the circle. O, point O refers center of the circle. And from the center of the circle, if you join any point on the circumference, how will you define circumference? The distance around the figure. The distance around the figure is called the circumference. And when we take any point on the circumference and join it from the center of the circle, then we call that length as the radius of the circle. Is it clear? So after getting a fixed point and taking any point on the circumference, for example, if I take A, then OA is the radius. If I join any 2 points on the circumference of a circle and the line is passing through the center of the circle, then this is diameter. This is radius. I hope you know the relation of diameter and radius. Radius is half of the diameter, or diameter is double the radius. Is it clear? Now I will take one more circle. There I will join 2 points on the circumference of a circle without passing through the center. Here in diameter I have joined 2 points. The condition, it was passing through the center of the circle. Suppose if I take PQ as 2 points on the circumference and join it, you will get the segment called chord of a circle. Diameter is also the chord of a circle, that is the biggest chord of a circle. This is the chord. We can draw infinite number of chords to a circle. A chord is a segment where the 2 points on the circumference of a circle get joined. That is, when we join any 2 points on the circumference, then it is called, the segment formed is chord of a circle. This is the radius of a circle, diameter of a circle. Is it clear? And further, when you enter for next year in the chapter area related to circle, you are going to study about segment of a circle, sector of a circle. I will show here also. You should aware about, when you before entering to the 10th, you should have some basic points based on the circle. You should aware about. Okay. So again I will draw a circle. All this circle figure you have to do it in your book, but either you should use any circular object or the compass to do. Don't go with freehand circle, okay? That is the reason I am using this compass in front of you. This is a circle with center O. And if I take any 2 points here, M and N, and join like this, OM and ON. And the region bounded between the arc and radii of the circle, we call it as sector. So this angle is central angle. MON, region covered by arc of a circle with the radii of the circle, we call it as sector of a circle. All the definitions you will get it in the textbook also. Otherwise, I will type it and I'll give up so that you can follow. Okay, but figure you have to write by yourself. Or if the explanation is sufficient, you can also write the Yes, in your notes, in your geometry notes, you have to copy it. Not now. Now listen the explanation. Again, I consider one more circle of any radius. Here, I am joining 2 points on the circumference of a circle like this. A chord you will get. Here, MN is a chord which divides the circle into 2 parts. Each part is called segment. This is major segment. This is major segment and here this is minor segment. Again, I will go back to the explanation. A circle is, I will give the figure in better way. Okay? I give the figure using the compass only. We define a circle as a circle is a set of points which are equidistant from the fixed point. That fixed point is called center of the circle. Okay, na? Take a dotted line like this. First figure, we define a circle. It is a set of points which are equidistant from a fixed point. That fixed point is called center of the circle. Then, from the center, if you join any point on the circumference of a circle, we call it as radius of a circle. And the line segment passing through the center of the circle from 2 points on the circumference is a diameter of a circle. Diameter of a circle is also called chord of a circle. The biggest chord of a circle is diameter of a circle. This diameter divides the circle into 2 equal segments. Each we call it as semicircular region, half of the circle. And the line segment joining the 2 points on the circumference of a circle is chord of a circle. Next, a region bounded by an arc with the radii of a circle is sector. S-E-C-T-O-R, sector of a circle. Okay? Whereas the region which is departed by the segment, that is by a chord, major segment and minor segment. Okay, na? These are the basic concept. I will continue again. So what you just see the figure and tell me how can we name this circle. Here I am drawing one circle with the same. Again I am getting one more circle like this. What we call these circles as? What we call these circles? Can you name the circles? You are busy with putting thumbs up, not answering to my question. What we call those circles? Don't know? They are called don't know, madam. Okay. You have not seen such a circles, Ashes? So far you have not seen? Here we define these circles with the same center but different radius are called concentric circles. What we say? Concentric circles. Because in the question if you may get to find out the radius, to find out the distance, so I am giving the figure. Circle with same center is same but different radius, they are called concentric circles. Clear? Concentric circles are those they have same center but different radius. Next, I will draw a figure. So the circle has been taken in three parts, that is interior of the circle, the circle divides the plane into three regions. Suppose if you draw a circle here like this, the whole circle can be taken as, this is exterior of a circle, this is interior of a circle, and this is on the circle. So the circle in which it placed divides the region into three parts, that is exterior of a circle, and this is interior, and this is on the circle. That is, by seeing the points in this region, we can identify the points interior of the circle, exterior of the circle, and on the circle. We can easily identify. So a circle divides the region in which it lies into three parts: exterior region, interior region, and the circle itself. Circle itself means the point, the circumference of a circle, interior circle, exterior circle. Is it clear? This is a very basic concept I am giving. Now we have the properties in the circle. Based on the properties, we have the problems. So circle has wide varieties of questions. Okay? We'll study it slowly. Don't get excitement. And this Sunday you don't have this chapter test. You have only 7 chapters test. Okay? This chapter is not included. You just listen and get the portions. Here, set of points which are equidistant from a fixed point. Radius is the line segment from the center to the point on the circumference. Chord is a segment joining 2 points on the circumference. A chord which passes through the center of the circle is a diameter. The region bounded between an arc and the radii of the circle. Radius, plural form is radii of the circle, is sector, major sector, minor sector. Similarly, a chord divides the circle into 2 parts, minor segment and major segment. And circles with same center, different radius are called concentric circles. And a circle into which it lies, that is, a circle divides the plane in which interior of the circle, exterior of the circle, and the circle itself. Okay? We can have, I cannot say all those things all together. So in between the lesson only you have point of asking. It's not correct, Shrikant. If you have any doubt after the class, you can send me the message. I can give the answer. Many times I just inform, don't deviate from the lesson is going on. You should bother about the lesson. Lesson, any question, I will give the answer. Okay? Is it clear? Have you all taken? If you have not taken also, the figure will be in your recorded part. You can take the notes later. Okay, na? Next. The instrument what we use to draw the circle is a compass. Here is exercise 10.1 question. Few question I'll read out. You may get the textbook question directly. Okay. The center of a circle lies in dash of the circle. The center of a circle lies in exterior or interior of a circle. Give me the answer. The center of a circle lies, yes, interior of the circle. Next. A point whose distance from the center of the circle is greater than its radius lies in the dash of the circle. Got the understand this sentence? A point whose distance from the center of the circle is greater than its radius, then it lies in the dash of the circle, that is exterior of the circle. Next, the longest chord of a circle is which is the longest chord of a circle? Yes, diameter. Next, an arc is a dash when it ends on the ends of a diameter. An arc is a semicircle. That is already I given. A diameter divides a circle into two equal parts. Each part is a semicircle. So the end points lie on the diameter. Then we call this region as semicircle. Okay. Next. Segment of a circle is a region between an arc and dash of the circle. A segment of a circle is a region between an arc and chord of a circle. A chord divides the circle into two parts, minor segment and major. Segment means it includes arc as well as the chord. A chord divides the circle into two parts. Next. A circle divides the plane on which it lies in dash parts. A circle divides the plane on which it lies in three parts. Which are those parts? Interior, exterior, and the circle itself. Three parts. It divides the region plane into which it lies three parts, namely exterior region, interior region, and the circle itself. And they have given true or false. I will read out. You can give me the answer whether it is true or false. Only if you are giving the answers. Please, I want everybody's interaction here also. A circle is a plane figure. True or false? A circle is a plane figure. Is it a three-dimensional figure or a plane figure? Yes, it is true. Next, sector is the region between the chord and its corresponding arc. Sector is the region between the chord and its corresponding arc. True or false? Sector is a region between the arc and radii of the circle, not the chord. It is a region between the arc and the radii, then it is a sector. Okay, na? False. Next. A chord of a circle which is twice as long as its radius is a diameter of the circle. A chord of a circle which is twice as long as its radius is a diameter of the circle. True or false? It is true. Next, if a circle is divided into three equal parts, each is a major arc. We cannot divide the circle into three equal parts. We can divide the circle into only two equal parts. Each part is a semicircular region. We cannot divide a circle into three equal parts. We can divide into only two parts. So the statement is false. Line segment joining the center to any point on the circle is a radius of the circle. Line segment joining from the center to any point on the circumference is radius of the circle. True. Yes. A circle has only finite number of equal chords. A circle has only finite number of equal chords. We can draw many. A circle has only finite number of equal chords. False. Okay, na? So here, in brief, I can give of the condition. A circle is a figure. It is a closed figure, or we can say that it is a simple closed curve without any dimension. It is a set of points formed which are equidistant from the center of the circle. So that point, fixed point, is called the center of the circle, and we can divide the circle into two parts by drawing a diameter passing through the center of the circle, and the segment joining from the radius to the point, any point on the circumference of a circle is a radius. We can draw infinite number of radius or diameter. The biggest chord of a circle is the diameter. Biggest chord is diameter. A region bounded between an arc. Arc means a part of a circle. What is an arc? Arc is a part of a circle. It is bounded by two radii. Then this region is called sector of a circle. A chord divides the circle into two parts. We call it as segment of a circle. Circle with center with different radius are called concentric circles. Clear? What else I taught? A circle divides the plane in which it lies into three parts. They are exterior region, interior region, and the circle itself. Is it clear to everybody? Is it clear? Now I will move on to angle subtended by a chord of a point. Take the heading. Angle subtended by a chord of a point. Get the circular region. One circle using compass or any circular part like this. This is the center of the circle. take a chord here. When we join to the center of the circle, then we say that is the central angle. Central angle X. It is formed by the chord. Like that we can draw any another chord. If you join like this, you will get another angle. This is also central angle. That is angle bounded between the radii with the chord is the angle subtended by a chord at the center. So now the question is, now the question is equal chords subtend equal angles at the center. I will give the statement. You have the proof of the statement, but practically also you can verify it. That is, to a circle, if you draw two equal chords and joining to its center, and if you measure it, they are equal in area. Equal in measurement. Okay. So now we define this as angle formed by the chord of a circle at the center. It is called central angle. Okay. Now the property is, as a theorem statement, theorem 10.1, equal chords of a circle subtend equal angles at the center. Theorem, this is chapter 10, so they have named the theorem as 10.1. Theorem 10.1. Equal chords of a circle subtend equal angles at the center. Like how you prepared the statements in lines and angles, in this chapter also you have number of statements with respect to the theorem. You have to repeat it. You have to write it again and again so that we can easily prove the problems based on that. So to the statement, consider the figure below the statement. I will show how we can prove that equal chords subtend equal angles at the center. That is, when the chords are equal, they subtend equal angles at the center. Take two chords which are equal in measure, AB and CD. Consider two chords AB and CD. Now join OA, OB, OC and OD. By congruency we can prove these two, and these two are equal. We have to prove these two angles are equal. That is, angles subtended by the chord at the center. When they are equal, when the chords are equal. Conversely, if they subtend equal angles at the center, then the chords must be equal. Equal chords subtend equal angles at the center. Conversely, chords which subtend equal angles at the center are equal. When we feel hungry, we will eat more. When we are eating more means we are feeling hungry. That is the converse statement I am using here, as when chords are equal, they subtend equal angles at the center. Conversely, if the angles are equal, then the chords must be equal. This is one of the main property of the circle. Okay, Maulia, you are present. You had to present double time because all these days we are absent. You are present now. Okay, every day you just give me your statement. Yes, Maulia from JSS Public School has present. I am happy. Now after the figure, now write the proof of the figure. Taken the figure. You all taken the figure. Now write the, you will get an explanation now. That is, AB and CD are two chords. They are subtending angles at the center. We have to prove AOB equals COD. Okay. Now don't write. Just listen and observe what I am writing. Then you will get an idea. Okay. I will write here, given AB and CD are two equal chords. Don't write now, just observe what I am writing and listen what I am explaining. AB and CD are two equal chords of a circle. To prove angle AOB equals angle COD. Construction. We did construction here. What construction we did? Join OA, OB, OC and OD. Since it is a construction, I have shown that in a dotted line. We have joined. Now here comes the proof. In triangle AOB and triangle COD, AB equals CD, it is given. In the question itself it is given the two chords are equal. OA equals OC, radii of a circle. OB equals OD. This is also the radii of a circle. So here all the three parts are matching. AB is equal to CD, OA equals OC, OB equals OD. By which congruency we can show the triangles? Congruent. SSS congruency. I think you have studied in 8th standard congruency. SSS congruency. Two triangles are congruent. Therefore, triangle AOB is congruent to triangle COD. Therefore, angle AOB equals angle COD. We call it as corresponding parts of congruent triangles. That means we can prove that triangles are congruent when all the three sides of one triangle is equal to three sides of the other, or two sides and included angle is equal to two side and included angle of the other, or two angles on one side of one triangle, two angles on another side of the other triangle, or by RHS. The statement all you have studied that we are making use in the congruency to prove the angles are equal. That is, when we draw two equal chords and when we join to the center, they are going to subtend equal angles. That means if you draw AB and CD with, for example, 2 centimeter and 2 centimeter, then when we join, they subtend equal angles. You can measure by protractor. You will get equal measurement at the center of the circle. This is the explanation of theorem 10.1, that is, equal chords subtend equal angles at the center. Is it clear? Take it down. Is clear to everybody now? In the question it is given, if AB and CD are two equal chords, you have to prove angle AOB equals angle COD. To that I join from the center the end points of the chord. Okay. Then considering two triangles showing these two are equal because it is given. These two are equal, they are the radii of the circle. When three sides of one triangle is equal to three sides of the other triangle, then the triangles are congruent. When they congruent, the remaining parts will be automatically equal. So we call those parts as CP, CT. I didn't mention here. You may get confused. So just I am telling now, they are corresponding parts of congruent triangles. When we go with the chapter congruent triangles, you will get it. I did start because already lines and angle is very dry chapter. If again I continue congruent, you may feel bored about it. This circle means at least you have the creative of drawing it. You may feel easier than the lines and angles. That's why I started this chapter. Okay, na? After the chapter, when you go with the congruent triangles, you will get it what this congruency, what this CPCT and all. And the statement of this converse, that is, here what we proved, if AB equals CD, AOB equals COD. Its converse, if AOB equals COD, prove that AB equals CD. Can you prove like that? For which congruency we can prove, any idea? Otherwise, no problem, I will teach you in the next class. Yes, any idea you have? How can we prove, by which congruency we can prove that AB is equal to CD? That is, if chords subtend equal angles at the center, they are equal in measure. Yes, very good, Shrikant. SAS, side angle side. By SAS, two triangles will be congruent, then AB equals CD. Very good. Okay, so that congruency is based on theorem 10.2. I will continue in the next class. This is not for your Sunday test. You have only 7 chapters for 30 marks for 45 minutes. Is clear? I will move on to the next class by tomorrow. Thank you. You all, hope I thought that you all understood this concept. Anyhow, with the figure, try to write the statements, listening the video. Still, if you are not able to write up the statement, you can ask me tomorrow also. I will explain it again. Okay, na? Thank you, children. Aishat present, Prajwal present, Tejas, Shrikant, Pooja, that means Adya, and then Maulya TR from JSS, Madhumita, Grishma, Kevin, yes, then Punya present, then who else? Samhita present, Ashes from DMS, Shrikant, Hamsini present, Aryan present, yes, and then Divya, Kaushik, Aryan also present, okay. Remaining, Vismaya, Aditi Shetty, Aryan, Shriha, Shreya, Prajwal present, yes, I noted Adya present, Tejas Manjunath present, but still many of them are absent today also. See, if you continue like this, I will give only online classes. I will stop these recorded classes because you are taking the advantage. Anyhow, we can see later. That is the reason you are not attending this seriously. Nishan present, Dhruti present, then Bhuvan. Yes, Bhuvan present, Grishma present, Tanya is not there, Samhita is not there. Okay, See in the next class. Samita present? Okay. Okay, dear. Varshini present? Okay.